Good afternoon, everybody, to another session of the Purple Talk Invite. This is week 7, and for today, we would be focusing on stacking, architecture, and configuration. This was supposed to happen last week, but because of the rains, we had to postpone it, and so we're conducting it this week. So, these are the conferencing numbers to join in for all future uh, Purple Talk invites. And to join the video, you can click on the link which comes along with the mail. So these are the topics that I would be covering for today. So I would be giving you a brief introduction on stacking, the benefits of stacking, hardware requirements for stacking, uh, the stacking architecture on how it is designed, and how the traffic is being handled, and we'll look at a few scenarios of about link failure as well. It's quite a big topic, but I've tried to include as much as possible. So let's hope I'm able to cover everything by today within 45 minutes. So let's first see what is a difference between a stack and a chassis. So the main reason for having stacking is uh, you have redundancy basically, just like as in a chassis. So in a chassis, you have I/O modules where all the data ports are connected, and then you have the two MSMs. And if one of the MSMs fails, the other MSM would take over. And the even if the MSMs fail, the data switching would continue to happen without any issues. So, but there are problems with chassis. So, but I'll give you an idea of what are the benefits of the chassis and how we can get those same benefits using stacking as well. So, one thing is it simplifies management because the whole chassis can be managed by a single IP address. And as I mentioned before, there is redundancy because if the MSM fails, you do have the primary, and there is a backup as well, so you have redundancy. uh, the only problem with chassis is that you require a lot of space, and if you're a company which is just starting off and you got very little employees, you cannot just go afford and a chassis based switch because it's quite expensive, and you would not probably have the space as well. Whereas in a standalone switch, what we can do is if you're starting off, the best thing to go with would be a standalone switch because it's less expensive, the one which we see below in this picture. And you just require one rack unit to fix this unit. And the benefit is that as your user base increases, you can add more slots. You can add more of these switches, these standalone switches, and you can get the not the exact type of redundancy as in MSMs, but you're quite able to reach the maintain that kind of redundancy. So you can have so we'll see how we can do stacking and then ensure that there is redundancy as well. So one thing with stacking is that as in the chassis based switches, you can also have a single point of managing the stack. So you can have just one IP address, or you can also assign an IP address for all the other slots in the unit as well. We'll see how we can configure all those. But so basically, with the chassis, you can stack up to 8 switches uh, as you grow, or you can start off with just 2 switches to do stacking, and you can manage the switches with just one single IP addresses. So basically, you get combined management. You have a single MAC address for the stack, and there is a you can have a single IP address for the stack. And the benefit is that you can just add each of these switches one by one instead of just purchasing all of them together. Because as your company grows, you're going to add one by one. And another benefit is that you can mix the type of switches that you have. It's not necessary you need to have all the similar kind of switches. So sometimes you may have you will require fiber-based switches, data ports, or Ethernet, etc. So you can just combine or PoE or non-PoE based AC or DC switches. You can just combine all of them depending on what your requirement is, and just add the switches. Um, and you get a good stacking bandwidth of about 320 gigabits per second. So this is for the stack, and and as I mentioned before, it's going to be much less expensive compared to your chassis-based switches. So I wanted to bring this out actually because many people had some confusion about how we can stack the switches. So in with Extreme, uh, we currently have um, two types of ports that can be used for stacking. One is the native, and the other is alternate. So with native, we're basically dealing with ports which are dedicated only for stacking. They cannot be used for data. So in most of the switches, the stacking ports would be native, but now we are bringing out switches which are have alternate stacking ports. So with alternate, you can use them for stacking, and if you do not require it, you can use them as data ports as well. So you have this option with alternate. So if you do not want to use it for stacking, just use it for your data ports, or vice versa, how you would like it. But alternate, one thing to note is will be that all the links would be 10 gigabit Ethernet links for alternate stacking. So I just wanted to show uh, what are the switches and whether those switches support the alternate stacking port. So on some switches, you would by default you would get only the native stacking ports, which means they can only be used for stacking, and on some switches you would get alternate as well as native. So if you go down to our concepts guide, you can from there you can see we have a table which lists which the ports which support alternate stacking and native stacking. So you can find this in our concepts guide. You can download them. So for example, you can see here, so on the top we have the X440 switches, the Summit X440 switches, and the alternate stacking ports are 25 and 26. So we have a big list here, so you can go through them when the time permits. So now for native stacking, uh, we these are the cable requirements. These are basically just the CX4 cables, and the part numbers are mentioned, and they are very short cables actually. They range from 0.5 meters to 5 meters. They are just the CX4 cables, and if your switches are very far apart, you would not be able to use these stacking cables. Instead of that, you can either go for alternate stacking, where you can connect the switches using fiber as well. So I got a picture of one of the CX4 cables here, which is for use for native stacking. So this is extreme proprietary, so you would have this connected like this between the switches. You will use these cables. One main thing to keep in mind for stacking is that you need to have the same software running on all the switches in the stack. So if you've got 8 switches, all of them should be running the same software version. And stacking is supported from version 12.0 and above. And you can download the images to the slots in the stack using this command: download image, IP address, file name, and the slot number. So thing to remember, most important thing is all the switches in the stack should have the same software version, and the master and the backup should have the same license as well. It's not necessary it's the standby units need to have the same software version. I will tell you what the roles are, etc., just to make you understand what I was mentioning about master and backup. So basically, master and backup is we will be dealing with them. So I will explain that. So these are the stacking ports, the native stacking ports that I was mentioning about on the back of the switches. So you would each port stacking port gives you about 20 Gbps. So for one switch you would be getting 40 Gbps. So totally for 8 switches you would have 320 Gbps stack capacity. Both these ports, I mean each of these ports are 10 Gbps full duplex. So this is how you would connect the switches on the back. So I was talking about the unit roles when you do stacking. So basically, just like in your chassis-based switches, you have a master and a backup, and then you have the I/O modules where you know all the users or the your data ports are there. So you have a master, you have a backup, and then in stacking also you have a master, you have a backup, and you have the standby units. So the master was what manages all the configurations on the unit, and it acquires the ownership of other units configuration as well. So basically all the configuration of the stack you would be doing on the master, and when you do a save configuration, the master saves it to the backup unit as well. And so master will also share the configuration, as I mentioned, with the backup unit. Functionality is similar to a master MSM as in a chassis based switch. So for the backup unit would take over the mastership if in case the master unit fails, and it does not own the configuration because it's owned by the master unit. All configuration should be done only on the master. Even if you log into the backup, you would not have an option to make the configuration changes. All should be done through the master unit. And as I mentioned, backup unit would it takes up the ownership in case the uh, master unit goes down, and it also takes co-ownership of the standby units. So as I mentioned, the backup unit is in functionality it is similar to the secondary MSM in a chassis. So standby units, these are basically just like the IO modules. They are essentially slaves to the master unit. ASICs, everything are programmed by the master unit. Functionality similar to an IO module in a chassis. So for a stack to operate, ideally you would just require a master and a backup, and the rest of the switches you can have them as standby units. Depending on how you want the configuration, you can have the standby units to be master capable as well. So it's very important to understand the the topology of the stacking architecture. It is always recommended to have a ring topology as the one that is described here, shown in this diagram here, the first diagram. So there are 4 units, 1, 2, 3, 4 slots, and they are interconnected to each other. So the 4th unit is connected back again to the first unit. So as seen in the green arrow. This is the best and the recommended setup, because in case in one of the stacking uh, cables or if the ports fail or one of the switches fails, you still have a redundant route. So uh, there is redundancy basically. But if you see the second diagram, which says daisy chain, there is no connection between 4 and 1. So basically it's just a single connection between 1, 2, 3, and 4. And in case the link in between 2 and 3 breaks, the stacks are going to get segmented. So you will have 2 different stacks, which is not good for you. So it's always recommended to have a ring topology. So I will explain about how a stack handles the traffic and what types of how the traffic is classified into. Uh, there are four types of the traffic is classified into four types. One is the topology traffic, basically the traffic between that is sent between the stack members alone. This is only for the stacking. And then we have unicast traffic and non-unicast traffic, non-multicast traffic, and the VLAN traffic, which is basically what you see in your network. So only the VLAN traffic. So basically into four types. So we'll see what is topology traffic. This is, as I mentioned, it's exchanged between the stacks. It uses the hop by hop protocol. As I mentioned, this is what is used to manage the stack, the master, the backup, the standby units. This is the traffic, and so as I mentioned, only these stack configuration messages are sent between the switches in topology traffic, and it consumes very little bandwidth, and it's processed by the CPU. So this is just the topology traffic to manage the stack. So known unicast traffic. For non-unicast traffic, the uh, so when you have 8 ports interconnected like in a ring, there is chances for a loop. So what the stacking does is that one of the ports on one of the units would be blocked, but it's not always that this secondary port would be blocked for all types of traffic. So for example, for non-unicast traffic, uh, this port would not be blocked because the traffic is not flooded. There is no chance for a loop. So for non-unicast traffic, the secondary port would not be blocked. Uh, so here I'll give you an idea about how the traffic is handled. So you have 8 units here, and so they're using they calculate the shortest distance to reach the next hop or whichever hop they need to reach. So and so for example, you see the green part here. It mentions 2 hops to unit 8 through stack port 1. So for the sixth unit, it uses this algorithm and it calculates that the shortest path, I mean, it's just 2 hops away from slot 8, that is slot 6 calculates that it is 2 slots away from stack port it is 2 hops away from unit 8 through stack port 1. And so if you see the yellow or I'm sorry, the orange part that is calculated by slot 3. So it calculates that it is 3 units away from slot 6. So 3 hops away from slot 6. That is how it calculates. So as I mentioned, units for unicast traffic, the traffic is sent and received on both ports. So it is handled by the switching fabric. ASICs are forwards to the source ASIC, switching ASIC forwards to the destination switching ASIC. So as I mentioned previously, no stacking ports are blocked for this kind of traffic. So all slots have an idea about where the other slots are and how many hops away it is to reach that. This will be useful for recalculating the path in case one of these slots fail. So this is for non-multicast traffic. As I mentioned, uh, for these kind of traffic, it is handled by the switching fabric as well. So each ASIC on the slots is aware of the relevant multicast configurations on the other units, and Uh, the redundant path is blocked in this for this kind of traffic. This is to prevent loops, and this is also based on multicast address. So if you will see here in the diagram, uh, slots 5 and 6, which are given in green. So each for each type of traffic uh, between these ports, depending upon the multicast address, the ports are blocked. So if you'll see here for green, slots between 5 and 6, the ports are blocked for address 1, and if you will see for between slots 3 and 4, the for a different multicast address, those ports are blocked between 3 and 4. So this is how it handles multicast non-multicast traffic. This is for unknown unicast. So as you know, uh, basically this is just the VLAN traffic. So if you do not know where the destination is, the switch is going to end up flooding the traffic. So that can cause a loop. So in this case, it is not like it doesn't handle this traffic as similar to multicast. For this one particular port between the slots will always be blocked for all the VLAN traffic. So it does not matter from which VLAN it is coming from, but for all of those traffic, the same ports will be blocked. This is calculated. This will be calculated based on the slot which has the lowest MAC address and the interconnected port number. So for this type of traffic, that particular port on that switch will always be blocked, irrespective of which VLAN it belongs to. So it's not as though the one particular VLAN for it'll be blocked for one slot, and for the second VLAN, the second slot will be blocked. It does not like that. It is always blocking one particular switch port is always blocking the traffic, the VLAN traffic. This is because flooding can occur and it can cause a loop. So let's see how the master backup election occurs, and so we'll get an idea. But how we can manually interrupt and change the master backup election process, or you can automatically allow it to choose the master and backup. So you can first the master and backup is the master is chosen based on a priority value of 1 to 100. The higher the better. So if it is higher, the highest priority will become the master first. And you can configure this priority if you want to make one particular slot the master, or you can leave it as automatic, in which case the slot number would break the tie. So the lower slot number, the better. So if there is slot number 1, that would become the master. Slot number 2 would become the backup, and so on up till slot 8. So when we verify the commands, I will tell you. So you can see how you can just enable stacking using just one command, and all these requirements will be not there. So what you need to do is, if you want one particular slot to be the master, you need to log in to that particular switch or on the stack to ensure that it becomes the master. So the slot number for that would become 1, and automatically the other ones connected to it would become the backup and the standby nodes. So how the stack operates. So the master is what handles all the configuration files, and as I mentioned previously, master shares the configuration with the backup. So there is a similar copy with the of the configuration file with the backup, and all the other units configuration is acquired by the master and the backup. The master implements the configuration. So basically, you do all the configuration on the master, and it saves to the backup. So uh, the master configures the backup with RPC like calls, and it uses the control VLAN, the control channel, to manage the stack. Similarly, it configures the standby units also with RPC like calls. So it does not matter exactly, that it's not necessary that a VLAN residing on, say, on slot 3, if you need to reach it, or if the traffic needs to be forwarded to somewhere else on the network, it's not necessary that it needs to go to the master or the backup. So uh, it is just that's the traffic can be forwarded if the source and destination reside on the same slot itself. Uh, the traffic can be routed or switched locally itself. It's not necessary it needs to go to the master or the backup or the other standby units. Say, for example, you have a yellow VLAN. You can see that yellow VLAN exists on slot 3 and on slot 7 as well. Whereas the red VLAN, it is only on slot 1. So traffic from within the red VLAN can be limited to just if the source and destination reside on the same slot. So it is if we say only we need to send only the traffic to red VLAN, um, only the traffic will only be sent on slot 1. It will not go to the other slots. Whereas if you see for yellow VLAN, it's distributed, so it will have to go through the other slots in between to reach the destination. So as I mentioned previously, the stack is manageable. Uh, you can use as a VLAN management. You can give it an IP address. You can give it a stack MAC address. You can configure the stack MAC address, or you can automatically uh, have assign it the stack MAC address. When it generally slot 1 or the master's MAC address would be the stack MAC address. So let's see how link failure uh, occurs and what it causes, what uh, happens to the stack when the link failure happens. So we've got 8 nodes here, they are all interconnected. So previously, as I mentioned, they calculate a shortest path algorithm based on hop, and so previously, if you will see, slot 5 to slot 4, they are both connected directly, and so if you see the green part, it mentions that uh, through stack port 2, U5 can reach U4, unit 4 can reach unit 5 can reach unit 4. So that is how uh, the algorithm it calculates. It's the shortest path. So this is how originally it was. Then say, let's say, take a scenario where the link between 4 and 5 breaks. So in this case, now they need uh, to calculate the another path to reach. Uh, so five, in case the link between 4 and 5 breaks, so 5 needs to calculate another path to reach 4, because we do have a redundant path which is using the stacking cable, but those ports are blocked. So blocked port is removed, and 5 calculates a redundant path to 4, which is 7 hops away. This is how, in cases link failure occurs, this is how it calculates. This is next we'll see a scenario which is a multiple link failure recovery. We'll see what happens. This multiple link failure, it will not generally occur, but we'll just see the scenario to just understand what happens actually. Let's say there are 8 switches, and the stacks segment each other. Actually, there is no connection between. So the stack segmentation occurs actually. So the stack gets separated. The master and the backup gets separated. The original master and the backup get separated from each other, and they do not have a redundant path to reach each other. So in this case, let's see what will happen. So when the master and backup are on different segments, uh, the segment with the master will elect a new backup master. Obviously, the master is there, so it's going to elect a new backup master, and a path is recalculated on all units to know where the units are and which is the best path to reach them. And switching ASICs are also updated for the missing units. So this is on the master. Let's see how the behavior is on the backup master. On the backup master, uh, the backup master is going to become the master itself because it's segmented from the original stack. And then it elects a new backup master if there is a master capability turned on the other units as well. So a new backup master is selected. As usual, the shortest path is recalculated to reach all the other units, and so switching ASICs are also updated for the missing units. The problem with this kind of multiple link failure and the stack segmentation is that, as I mentioned previously, the stack actually has a single IP address and a single MAC address. When this stack segments, the problem that we will have is that both of these stacks after the segmentation is going to have the same IP address and the same MAC address, because the stack MAC address also is going to be the same and the IP address is also going to be the same. So we'll see another scenario which is a multiple link failure. It's highly unlikely that this kind of a scenario would occur, but just to understand what would happen actually. So when the segmentation, in case the segmentation occurs in this scenario, and the master and backup end up being on the same segment, and the standby units, for example, are on a different segment. In this case, what would happen is if there is master capability turned on the standby units, the standby units would elect a new master and a new backup master as well. This is for the standby units, and they would calculate the shortest path, and ASICs are updated. And whereas in the segment with the master and backup, the switching ASICs are updated and they just recalculate the paths to reach the different nodes. So let's see how we will enable the stacking on the switches. So we would just connect the 8 switches to each other, apply power to the units, and most important thing is that uh, you would need to log into the switch that you want to be, that you intend to make it the master of the stack. You would need to log into that, so automatically that becomes slot 1, and when you enable the stacking, that would become the master. So you log into that particular slot. So you can remove any legacy stacking configuration which is there using the unconfigure stacking command. So first, most important thing to note is that you need, after the switches are connected with each other, you need to execute the command show stacking. So when you do show stacking, you should be able to see the MAC address of the rest of the nodes which are connected using the stacking cable. So unless you see the MAC address, do not go ahead with the stacking, because You would end up trying to configure stacking. You would execute all sorts of commands. But if the switches are not detecting each other and they are not detecting each other, you would not be able to. The stack would not form. So you would be wasting a lot of time on just uh, trying to enable stacking. So first step is you need to do the show stacking command and you need to see the MAC address of the rest of the nodes. I think I have. I do not have that output here. So we'll see that later. So then next thing to look for would be to configure the license level. So if you want to restrict any particular slots, you can use the configure stacking license level. The thing to note for the license level is that the master and the backup should have the same license level. It's not necessary. The standby units need to have the same license level. So those license levels can be changed using the configure stacking license level command. So the next command that you would enable is enable stacking command. And the easiest and the best way to do is we have something called as stacking easy setup. So give yes to the easy setup command, and the the stacking would be automatically configured. We'll see what are the commands that are executed when you use the easy setup command. So log into the switch with admin privileges. The safe default scripts will run. Select values for normal operations. So you need to give yes for which operations that you require once you are logged in. Verify that the master node is the one you intended to be the master using the show stacking command. Again, you can execute the show stacking command and you can see the difference. Only difference here is after the stacking uh, is enabled. If you do the show stacking, you would see that you would see a master, a backup, and the remaining as standby nodes. Whereas before stacking is enabled, if you do show stacking, you will see the MAC address, but the roles, all of them will be master. So since each stack is not, I mean, each slot is not aware of the other person, of the other stack, is going to consider itself the master, and so everything will show as a master on the stack. So you can verify the remaining of the configuration after doing the show stacking command. There is another command which is show stacking detail. You will get a lot of information in that, and you can just save the configuration. So I told you you can use the easy setup command. So enable stacking easy setup. I'm sorry, configure stacking easy setup. So these are the commands that it would execute when using this command. It would execute enable stacking, configure stacking slot number automatic. So automatically it's configured. So the switch on which you are logged in would be 1, and the consecutive ones which are connected after that would be 2 and 3, etc. until 8. Configure stacking MAC address. So since the whole stack needs to behave as a single switch, it needs to also have a single MAC address. So you would the stacking MAC address is configured as automatic. So the master's MAC address would be the generally be the stack MAC address. Configure stacking redundancy minimal. So there is three types of redundancy: none, minimal, and maximum. In minimal, you would have one master and one backup. In none, there's just uh, uh, no no backup, etc. And if it is maximum, all the slots are configured as master capable. So all the slots can become master. So that's the difference. We'll see that command later on. And then the last command would be reboot stack topology. So after this, the entire stack would reboot, and also and the stack would be enabled. So you can also enable stacking on one particular node alone, or so for that the command to use would be enable stacking node address and the node address. Node address is nothing but the MAC address of the slot. Another thing to note is that when stacking is enabled, the QoS profiles QP6 and QP7 are unavailable because that's reserved for stacking. Uh, then prompts for easy setup if stack is unconfigured or configuration inconsistencies. If you're not sure about how to enable stacking and what are the commands to execute, you can go in for easy setup. It's one of the most easiest things to do. It's just one command. So until stacking is enabled on the stacking links, there is no data flowing. So those there is no data flowing on those links. So until you enable stacking on them. So if stacking is disabled, they will not become a member of the active topology. And as I mentioned previously, as long as they are not aware of the other nodes on the stack, each will consider itself to be the master, and they will configure their configuration will be saved locally. If you want to check the configuration, you have another command which is show stacking configuration, and the uppercase E flag indicates if stacking is enabled. Default is by default stacking is disabled on the switches. You have to enable it. So this is the command to configure the slot number. Configure stacking slot number automatic. Configure stacking node dash address, the MAC address of the slot, and slot number. So you mentioned which is the MAC address, and if you want one particular slot to be to have a particular slot number, you can mention that. So these are, as I mentioned previously, the current node which you're logged into would be assigned the slot number 1, and that's how it is. The remaining, the backup, etc., is configured after that. So this is a good command, the node address, because if you can target a particular slot number, so you want to change the slot number, etc., you can give the node address and then change the slot number, etc. The easy setup, as I mentioned, it would execute this command: configure stacking slot number automatic command. So once stacking is enabled, the port numbers would be displayed as, for example, if it is 3:22, it means it's slot 3 port number 22, just as in a chassis based switch. So this is how the port numbers would be displayed after the stacking is enabled. So as I mentioned previously, you need to configure stacking MAC address, or if you use the easy setup command, automatically the stack MAC address is configured. You want one particular slot MAC address to be used as the stack MAC address, you can use that. So this will be the command that you use: configure stacking MAC address. And if you want to use the MAC address of another unit to derive the stack MAC address, this would be the command you use: configure stacking node address, the MAC address of the slot. Or if you want to use just the slot number, you can use the slot number command: configure stacking slot number and the MAC address. So you need to restart the switches for these commands to take effect. So I was talking about redundancy using that command when we use the enable stacking easy setup command. So I said there are 3 options: none, minimal, and maximal. So when you say none, only one node has master capability turned on. and minimal is you have two nodes that are master capability turned on. It's better to have at least minimal configuration, at least so that in case the master fails, the backup is there. Or you can have maximal, which is all nodes have master capability turned on. So even if the stack separates, the standby nodes, any one of them can become the master and the backup. So skip this. The reboot command for the stack, there is a lot of commands. So you want to reboot the entire stack, you can use the command reboot stack topology. Or you want to reboot a particular slot number, you can mention reboot slot number. Or you can use the reboot node address with the MAC address to reboot a particular node. And if you can use this command reboot stack topology as standby. Specifies that all stack nodes that are to be rebooted are to operate and if configured to not be master capable. So when that after using this command, that no particular node which comes up would come back up as a standby node. They would not be master capable. So for the easy setup command, it uses the reboot stack topology command. So best thing to do would be to use the reboot stack topology command. This is when you're enabling stacking on all these switches at the same time. So this is to configure the IP address on the switches. So you want all the you want IP addresses on all the slots, or no, just to manage the particular slots. You can use this command, configure stacking alternate IP address, and so it assigns a secondary IP address to each node on the slot. Or if you want to assign a particular IP address to one particular slot, you can use the second command, configure stacking node address. You mention the MAC address, slot number, etc., and the alternate IP address with the net mask and gateway. And to check the stacking, you can use the show stacking configuration. By default, there is no alternate IP address configured. You need to configure them. So this is the command to configure the license level. Configure stacking node dash address, license level, and what license level you need to configure. This is actually only for the stack. It does not actually change the installed license level on that particular slot. So this is just for the stack. So depending on how you require it, you can use this command. And as with the previous stacking commands, you need the command takes over after restart of the particular node. Synchronized stacking. This is a very important command. This is so when you do enable stacking, or if you're adding a new node to your stack, this command is very useful actually. So when you do a synchronized command, this is what happens actually. The stacking mode is command, the stack MAC address is synchronized, failsafe account and password, failsafe access point permissions, and the selected partitions. So whatever is stored in the master configuration, etc., is synchronized with the new node that you're adding. So the synchronize command is very useful command. It takes effect after the reboot as with the other stacking commands. So this is the sample show stacking configuration output. So you will see on the left hand side, you see the MAC address of the different slots. So what is this configured slot number and what is the current slot number, the priority, etc. And if you see on the right hand side, you have the different flags. Capital C means master capability is turned on, and capital E means the stacking is enabled. This is another important part in stacking because I get a lot of calls with people requesting me on how to add a new node to the stack without interrupting an existing stack. So let's say there are a stack of four switches and you need to add a fifth slot to it. Maybe it failed and you're replacing that switch with a new switch. So since it's not part of the stack, you need to enable stacking on it, and you do not have to reboot the existing stack of four switches to add the new member. All you have to do is reboot the new node alone. So first and foremost, connect the cables, etc. of the slot 5, as in this example, and do the show stacking command from the master. Execute this command show stacking. So you should be able to see the MAC address of the new slot, and then the commands that you would execute are as follows: configure stacking, node address, MAC address of new switch, and the slot number. Slot number would be 5. And synchronize stacking, node address, MAC address of the new switch, and reboot node address, MAC address of the new switch. So only the new node would reboot and it would automatically join the stack. After this, just execute the show stacking command once again, and you should see the new slot added to the existing stack as slot number 5. So that's all for this session. We were run out of time also. So there are a lot more topics to cover. I mean, in terms of stacking, but we do not have so much time. So we will conclude with this. I hope uh, this session was useful to everybody, and thank you for watching. Hope you guys have a nice day. Bye bye.